somewhat similar to the last section. Like our goal was to knock everything down. Oh, this has already gone through a lot of abuse. This thing is probably, I don't know, who made this one? I'm gonna guess at least 10 years old. We haven't done projects for 5 years, so. Well, we had COVID for a handful of years. COVID for 2 years, wind time, and then now we haven't been able to finish before the AP test, so we have to test after the AP test, so we haven't done projects for a while, so I'm kind of, hopefully these will last. I don't know. I didn't read it. So, our goal is to integrate the area of the cross sections. And that's going to be exactly the same on this section. So that's kind of why I presented it that way when we did objects coming out of the base. You integrate the area of the cross section. Now what's going to happen is we're going to be doing rotating and revolving. So I believe this one was supposed to be like a little portion of cosine of x, right? So it's 1 on the x 0, and then it kind of represents the cosine from negative pi halves to pi halves. And what we're going to do is rotate. So this particular one, if we rotate it around the x-axis, would give you somewhat of like a football shape. Okay? A cross section, so if we slice it the way it's rotated, the cross section would be a circle. And so what we would be doing is integrating the area of the circle. Now the nice thing about rotating is that it always creates a radius, because your axis of rotation is where radius starts. And so let's say the function, right? Like say this is cosine x. It doesn't say anything on here, I'm just kind of guessing. Let's say it is cosine of x. Well, that would be the radius itself. Because the distance from the x-axis to the outside of where you're rotating, so the radius, would just be cosine of x minus 0. And so I tried presenting things in the last section the same as you're going to see them in this section, because when you understand that they're all kind of the same type of problems, it becomes very easy to do. You just have to know which equation to integrate. Whether you're integrating the area of a circle, this one was the area of a semicircle, this one is, this is also, I can't remember the function. The function was sine of x plus 2.5 rotated around the x-axis. So sine of x plus 2.5 creates like that little wave, but it was raised up. And then it was rotated around the x-axis to create this. And then the way she created the project was to show the cross sections, right? Like wherever you look at the cross section on this, it's a circle element. Yeah. This one is probably not as what you would appear to think of this at first. This one is intended for you to view it from the side. Okay? And what we're going to run into later in the section is that it could be hollowed out. Right? And so, depending on the equations you have, is going to change the volume. This one, apparently, 4y was one of the equations, and then y cubed was the other. So it was the intersection of those two graphs, some little sliver shape that was rotated around, and that created this with a hollowed out inside. This one's a little bit harder to see just because of the way it was created, but I thought that was pretty creative the way they made it. Okay, so I kind of wanted to show you what they would look like first, so that you can picture it in your head as we're doing it. The good thing about this section is that there's actually pictures for some of the stuff. So The cross-section one, the last section, is much harder to put on a computer, unless you're like actually a graphic designer and know how to set up the CAD and all that kind of stuff. So here's what we're doing. This first example, it says right here that this section was made by the x-axis, the y-axis, and then for whatever reason, the equation of the line is written as x plus 3, y equals 6. Now, I think that's the same equation we did yesterday. So I'm sure this is just for consistency's sake. And then looking at this, I don't have a... There we go. Looking at this one, this was created by rotating around the y-axis. So that triangular shape, the region R, was rotated left and right. And then it creates the cone right to the right of it. I will always try to show the rotation somewhat like this so that you guys can at least, try to picture it in your head. And I tried introducing cross sections the section before. That's what this is. This is a disc. So the cross section is a circle, but it's technically a disc because it's volume. That's why this section is called disc and washer method, because the cross sections are going to look like discs, or if it's hollowed out, it would look like a washer. They're the exact same topic. Okay, so down here, we're going to actually set this up together. Aiden, why do you do that every day? Oh, are we studying other classes or what?
Yeah.
But doesn't that make it busier for you to try to learn calc later? Okay. I mean, you've done it so far. It's not like it's new for you, but still. Okay, so we want to integrate the area of the cross section. I'll just set it up like this to start with. Now, traditionally, a lot of people will draw the cross section. If you want to draw it directly on the picture, whatever, fine, go for it. Ours is drawn right above it. The rotation was around the y-axis, which means it's perpendicular to the y-axis. So this is going to be the radius. And we're actually going to call it capital R for right now because in a couple problems we'll have two different R's. So capital R. If you would like me to write a note on here, big R will always be the distance from axis of revolution to the outside of the object. So the axis of revolution is what you focus on most for these problems, because that's kind of what creates all of the information. On this one, the y-axis is the axis of revolution. In the last section, they specifically used the words perpendicular to the y-axis, but in this section they don't. They say it's rotated around the y-axis, but it's the exact same thing. So if we draw a line from the axis of revolution until we hit the outside of the object, that's going to be the radius. And I'm phrasing it that way because of what's coming up in the future. So over the next two sections, these same questions, they get more complex. But if I phrase it this way now, it's the exact same thing for all the problems. You mean like right here? That's also capital R. It's wherever you draw it. It's similar to yesterday when we drew our cross section. It's different wherever you draw it, but we're not putting specific numbers on it, so that's why it doesn't matter where you draw it. Okay, so on this one, we need to know where the two endpoints are to figure out how long the radius is. Well, the endpoint on the left is easy. That's at x equals 0. It will never change because it's always on the y-axis. The right-hand side changes depending on where you draw the radius. And so since it changes, it's an equation. And it's got to be x equals just because of the way we have this set up. So we need to take, oh, actually, I think it was, how was it written above this? X plus 2y equals 6? 3y. Okay, so we would just solve it for x. And so x equals 6 minus 3y. So this radius is 6 minus 3y minus 0. If I want to write that somewhere, I certainly can. R is going to be 6 minus 3y minus 0. That's how long it is. And yes, I know writing minus 0 is stupid. I'm purposely doing that because as these problems get more complex, it will be the exact same setup if I show it this way now. So that's the only reason I am kind of doing overkill on this. Because if I teach you the full method to start with, then the harder ones aren't harder.
So will we be getting to where minus 0 is a different number?
Mm-hmm. That's 6 point, what are we on now? 7? 8? 6.9? Are we in section 8 already?
We skipped what? Wait, 8.9?
8, yes. We're on 8.6. 8.6, okay. Okay, I'm really screwing you guys up with the numbers. I'm doing a great job there. Don't worry, your math teacher's great with numbers. What you guys will find at college, FYI, your professors cannot do arithmetic. They're terrible at arithmetic. They're super smart in concepts. And they know how to do every difficult concept thing there is. But they can't add, subtract, multiply, or divide for the life of them. It's just how it goes. You'll find it's the weirdest thing ever. The smarter the person they are, the less they can do arithmetic. It's because they don't care about the arithmetic. They care about the hard thinking part. That's why they have teachers' assistants. They do the arithmetic. Okay, area of the cross section. Now that we set up some stuff up there, ours is a circle. So a circle is pi r squared. So pi, the radius, is what we just wrote right there. 6 minus 3y squared dy. Oh, and Sade, you're on the laptop too? Why is everybody on their Chromebooks? Are you guys trying to study for other tests today? Oh. I sort of understand, but then you're kind of screwing yourself over for kelp too. I know it's a hard balance, but that technically is what the night before is supposed to be for. Or the whole week. Okay, who should we go with? I need somebody over here. We haven't called on this side for very much. That was a good volunteer. Alex, what am I missing on this problem? I'm missing one thing.
The interval.
The numbers. So the lower bound and the upper bound. Okay, so 0 to, I think it was written up here, yeah. So because we are doing this in terms of y, we are going to be integrating from that y value to that y value.
So 0 to 2.
Yep. If the equation had x's in it, then that would be from 0 to 6. Okay, 0 to 2. Alex, who are you going to call on?
We'll do Nolan.
I felt like that was almost immediate answer, yeah. Nolan, how would I integrate this?
I would FOIL it out first.
Yeah, there's different ways we could do this. One, me-
U substitution.
one method is foiling it out and integrating them individually. The other method is U substitution. Whatever's going to be quicker for you is what you should do. I'm just going to FOIL it out because that's what you wanted to do, so we'll write it. So we've got 36 minus 36y?
Yeah.
Yeah. Plus 9y squared. dy. And yes, U substitution would give you the same information, just presented differently. Do you want me to write the U substitution answer above it? So pi integral 0 to 2, you would need 6 minus 3y squared. I like how I wrote 3 if I said 6. 6 minus 3y squared times negative 3 dy. So negative 1/3 would go out front. So it would be a similar question, just set up totally different. You get the same answer either way. Okay, do we need to do the actual integration? I feel like you guys are pretty good at oh, yes? Okay. So if we integrated the U substitution, I would have negative pi thirds times 6 minus 3y cubed divided by 3 slash, so I'll make this divided by 9. And that would be from 0 to 2. What'd you say? So when I did 6 minus 3y to the third power, I would have to divide by 3. And so I combined the two 3's in the front.
Right.
And if we did the FOIL method, we would have pi times 36y minus 18y squared plus 3y cubed. And it doesn't really fit here, but that would be also from 0 to 2. Now, I can tell you from experience, the hardest thing to remember is the pi. You guys are so used to, like, when you do a square. Well, the area of a square is the side squared. And you guys absolutely understand that the area of a circle is pi r squared. But when you're doing these problems, you're so focused on trying to write the radius, because that's where all the info is, that it's easy to forget the pi. So do your best to try to remember the details. I understand it happens, but I'll just tell you right now, that's usually the hardest thing to remember. Go ahead. You got a question on it? You're just trying to put it together in your head? Okay. Anybody else want me to answer anything from either one of those setups? Should we move on? Okay. How difficult does this question feel for you so far? Does this feel somewhat like the last section? Obviously set up different, but okay. That was my hope. Okay, this is why I basically told you all this part. Okay, so this one just gives us one equation, even though it intends it to be the same. On the AP test, they would have better wording here that would say the region created by the x-axis, the y-axis, and y equals negative x plus 1, something like that. So it's obvious from this picture that that's what's intended, because when we graph y equals negative x plus 1, it would create this little tiny triangle. Oh, that was such a terrible line. You know what? I'm going to do that. Just pretend I drew that. Okay, so this goes from 1 to 1. I mean, it's a very small one. And it says revolved around the x-axis. So that is being rotated this way. You can put that revolve symbol wherever the heck you want. It doesn't really matter. All that matters is we're going to draw the radius. Would it help if I drew the three-dimensional shape up there or not? Oh, all right. Oh, I can do an arc? I love it. It is not what I wanted. So I got to draw it from the middle? Nope.
Do that, rotate 90
Yeah.
degrees.
What'd you say? Finish asking your question. Did you figure it out? Okay. Seriously, I can't stretch it? Oh, I bet. This is dumb. This program is terrible. Okay, there's the cone it would make. Our radius would absolutely go from the axis of revolution. If it helps for me to label these, I certainly can. I'm just going to call it AOS because I don't like writing that. Axis, oh my God. Let's just pretend. This is a long week, okay? Long week. Revolution. I wrote axis of revolution on the definition on the previous page. So the radius is always how far it is from the axis of revolution to the outside of the object.
Oh, yeah.
Sure. You always start at the middle, though. You start where it's rotated from and then go out. Nolan, who are you going to call on?
Can I just pick a number?
Yep.
I picked 7.
How come you started off the hour with a very specific call on, but now it's a number?
Because I don't want to pick on anyone else.
Just Alex?
Just Mickey?
Yeah. I'm just testing. making
Understandable.
sure.
Understandable, yeah. Okay. What number?
17.
That's Alex.
Oh. Wait, can we go with them again? Make sure you're paying attention.
Wow. That
That's cool.
if that happens, then I feel like Nolan would go again too.
So, are we going with Alex or should I pick another number?
Pick it up.
Are you ready to go a second time?
Yeah, I'm good.
All right, Alex. What's the length of this radius? And I can help guide you if you want.
Wouldn't it just be negative x plus 1?
Perfect. So the bottom is at a height of 0. The top is at a height of negative x plus 1. So that is going to be the length of the radius. Okay, Nolan, help me set up the integral that would find this answer for the volume.
So you use like volume of cone formula, right?
Yep.
So
Oh, no, back up. If we were doing this geometrically, yes. We are specifically only looking for the cross-section area.
oh,
So this particular cross-section isn't a cone.
yeah, it's a circle.
Yeah, if because the formula for volume of a cone would have different information than what we're focused on.
So it's just the integral from 0 to 1
Good?
of I times negative x plus 1 squared
Perfect.
dy
X.
dx.
Basically, whatever variable you're writing right here is always going to be that one. Okay, good.
Oh,
Go ahead and ask away if you got questions on what's written up here, but this is correct.
So in order to determine like x equals from 0 to 1, is it?
So this one would start, oh, that's not 0.
what are you trying to solve for?
X equals 0 to x equals 1. Because everything written in here is in x's, these would have to be x values as well. Everything kind of ties together. It has to be the same information. Okay, I didn't want to integrate this one because it's almost identical as the last one. You're going to find the integration for a lot of these is pretty much the same.
Oh. Boy, I think
Do you feel pretty good about all these questions that we just did, too? Okay, then I want to skip to washer method, which is the next page. And for most students, go ahead.
So the stuff we just did, is it always gonna be areas of circle?
Yeah.
Oh, seriously?
Disc and washer method, the fact that you rotate it around something automatically creates a circle. So if you have any type of a revolving or rotating question, it's circle.
And the answer for that is just give, that gives the volume, or does that just give?
Correct. Yeah, the answer is the volume. You're right. I forgot to write units cubed on the first one, didn't I?
I don't think we actually went through that.
Oh, yeah, we didn't find the actual number answer. Yeah. Okay, most students feel like this is more complicated. Like just looking at the pictures for one, it feels more complicated. What I really dislike about this picture over here is it's trying to make it look 3D, which kind of just screws up your eyes trying to look at it. It's basically a literal washer. Like most of you know what a washer is, I think. No, it's a little circle piece of metal that goes through a bolt. When you have a bolt or a screw, you put a washer on there so the bolt or screw doesn't damage what it's going up against. They're called washers. If you want to think, it's like a coin with a hole in the middle. Okay, so like this one has a quadratic equation right there, probably, and some sort of a straight line. And the area made between them was rotated around the x-axis to create this weird looking, it would be a cone that doesn't have uniform density throughout it. It would absolutely look like some sort of a cone, like the end of a horn. It would be hollowed out. This would look like the end of a trumpet or something, or a saxophone. Yeah, I'll try to draw them on the problems. That's what this is showing you. Welcome. You didn't miss anything at all. Yeah, we moved into three-dimensional volume. Okay, here's one down here, which I think this is possibly the picture up above. So 1/2 plus x squared is one of the equations. Okay, well, let's draw that. What's the other one? X. So I guess I will make this 1 again because it's all taking place very close together. Oh, yeah, it's going to go up above 1, isn't it? Okay. 1, 2. I didn't hear you at all. Well, Emily, what was that? How do I know what? Oh, I just looked at the equation that they gave me. 1/2 plus x squared is very close to the origin. And then y equals x is on the origin. And incorrect, 0 to 2. So the x-axis, you wouldn't have to go past 2. Most of the time it's given to you. This one just wasn't. I've just done a lot of problems, so I kind of already know. Okay, so 1/2 plus x squared would start with the vertex at 1/2. It would go over 1, up 1, over 2, up, come on. I love how I just talked about doing a million problems, didn't I? Experience also teaches me to just make it look like I knew what was going on from the beginning. And I need a bigger, fatter pen. And so I'll just make it bigger and, cheat. I realize it's very difficult for you to do that on paper. Never happened. This is what experience gets you. Learning how to cheat and make it look like you knew what was going on from the start. So I would go over 2 up 4, and that would put me up 4.5. I mean, if you guys are using pencil, you just erase and then change your scale. Oh, actually, I don't want to draw past 2. Well, our interval's only from 0 to 2. Okay, y equals x would go from 0, 0 to 1, 1 to 2, 2. And the region created by those I probably don't want to shade it in just because I want to be able to draw the revolved picture. Is this the shape that's up on the top? It's kind of what I figured. So do I need to draw the revolved picture? Okay. Here's what you do want to write down and highlight. Remember how big R, you probably already wrote this down. We now have 2 different radii because we have 2 different volumes. We're going to subtract out the hollowed out volume. Distance from axis of revolution to outside of shape. Little r is how far it is from the axis of revolution to the inside of the shape. Now, disk method, you're not going to have an inside of the shape. You're not going to have a hollowed out portion. So if your shape sits flush or right on the axis of revolution, you're only going to have 1 radius. If your shape is not directly on the axis of revolution, you're going to have 2 radii, and it would be considered washer method instead. This one is not because the axis of revolution was the x-axis. So since our shape isn't directly on it, we're going to have a gap in between. They're both done the same way. It's just you need 1 radius for disk method, 2 radii for washer method. The key part is that you draw from the axis of revolution. So little r, I'm going to draw from the axis of revolution to the object. And when I hit it, I stop. That's going to be little r. Big R, I'm going to draw from the axis of revolution to the outside, and then I stop. The key part is where they tell you the axis of revolution is, because that's just creating all the information. And then once you have this set up, you would want to figure out how long the line is, how long each radii is. So the blue one, the top of the line is at a height of this parabola, so 1/2 plus x squared. Oh, what happened to the writing? Oh, there we go. The bottom of the line is at a height of 0. Oh, so Lou, this is actually pretty much the exact same as yesterday. Our cross section is just a circle now. Little r, the top height is on this straight line, so it would always be a height of x. The bottom of the line was a height of 0. So if you want to calculate this stuff away from the problem, you certainly can. Some people just like to write everything all at once. However you want to do it is fine. So I'm going to write these off on the side because I feel like some of you need this. Big R will be 1/2 plus x squared minus 0. Little r, x minus 0. And I always write it as top minus bottom because our top and bottoms can easily change later. So next section, we're going to start revolving around an axis that's not X or Y axis, it's just wherever. And so then that kind of changes things. Okay.
So the volume of the hollowed out part, you use the middle argument.
Yeah, so for this problem, the volume is going to come from the big shape minus the little shape. So you take the outside volume, subtract out the hollowed out volume. Some people like to write pi in the front of the integral symbol and then just do big R squared minus little r squared. Do it however you want. So for this one, I would have the integral. We're doing vertically, so 0 to 2. Of pi times 1/2 plus x squared squared minus pi x squared. This is all dx. I realize this is a lot of info to shove into you on a Friday, because at the end of the week, your brain hurts a little bit. I wasn't going to try to overdo it today, but I wanted to make sure to show you both methods, because I know the problems are kind of intermixed together. We absolutely are going to have time to work on these, but the fact that all of these remaining sections are all similar to each other, it's easier to try to teach them all together and then give you time to work on all of them together. So I know that's difficult and tough, but it's kind of just easier for your brain that way. I wanted to do one more, only because it's a calculator question. I want you to try to put it in your calculator. We don't have to draw any more stuff, really. We just, now we get to the point where it's typing everything in. So like this one already gives you a drawing. That's where I thought would be a good one to do it. I did not hear you. Oh, gotcha. They forgot an equation in the directions. I'm assuming that's x equals 2. But they forgot the equation in the directions. I believe this is supposed to be x equals 2. I mean, looking at the picture, it looks symmetrical, so.
Wait, I think it's on
Ours has
two on
the
ours.
graph.
Yours has a 2 on there?
Yeah.
Oh, all right, good, 2. But they still forgot to write the equation up here. So this particular region would need 4 equations to come up with that blue shaded area. And we only have 3 of them written here. Not a huge deal. Yeah, because that's what I was trying to set up for you. So here's what I was hoping you could do. Write out the integral that would find this volume all on your own, and then type it in your calculator to get an answer. Apparently to 3 decimal places. Make sure you use the pi key. Don't enter 3.14. Did anybody type it in and get an answer yet? Or are they just not confident?
26.389.
Okay, I'll put it up here and then we'll see if others confer. Did anybody else get a different answer? You got that? Okay, we've got seconded and thirded so far. That's what you got too? That sounded pretty solid then. This is a good one for you to practice the fact that you should know how to type this in by now. And if you don't, I can certainly help you out, but you should know how to type it in by now from our homework, from whatever. Okay, I'm going to stop there. I mean, I know it's not like we got a ton of time to work, but if you want to just try the first problem in the homework, that way it'll try to set it in your brain a little bit. Don't feel like all this homework has to be done by Monday. If you can, I would try a few problems from each section. And then I'm going to teach section 7 on Monday, which is this idea, but stepped up. And then we will absolutely have at least one day to work on them together. So, oh, shoot, that's Tuesday. So that'd be, I guess, Wednesday. I forgot about the ACT day. No, Tuesday you don't have school. I'm not going to be that cruel that I'll plan Tuesday as your work day. That would be pretty harsh. I mean, it is your work day technically for in Schoology, just as an FYI, but half of you are going to be studying for the ACT, so. Oh! How many in this class are seniors? Okay, they sent us out the schedule for the end of the year. I don't know if you remember how I first put up those dates for our tests. Well, the date of our last test was going to be May 31st. And apparently, May 30th is the last day that seniors are in class. So we're going to adjust those dates of the tests a little bit so that all 3 are done the Friday before. So rather than having 5 days of review, we'll have about 4 days of review per unit.
So this is one test per unit, or you're not gonna have like a big challenge?
No, just 1 test per unit, yeah.
Or you do what Mr. Sullivan did last year and just make it so seniors don't have to take the test.
I could.
That's what Mr. Sullivan did.
Oh, so you would like no grade for the whole trimester?
No, just the last test.
Oh,
Just
sure.
that last
Yeah,
test.
you want that last test. It's going to be the easiest one. Yeah, no, you have to take it anyway.
So sad.
This is an elective class. Come on. Why would you take it
Well,
thinking
doesn't mean I want to take tests. Even if it's an elective, I don't think anyone enjoys taking a test.
that's how you get a grade?
It's how you get a grade, but it's not necessarily the most enjoyable thing. Like, even if I take, like, I don't know, like orchestra, it's not an elective, I don't enjoy doing the playing tests. It's a lot of pressure. I enjoy the class, but I don't enjoy
Well, I hope your feelings change slightly as you have at least 4 more years of doing it.